Hello. Hello. Welcome back. So, last time we went through a little bit on new features since the time before, because I had a lot of features being made with the help of AI. And we started a little bit on the importing modules and stuff. And from what I remember, we started on phase 1, where basically we did these things. And this is kind of like AI's plan here, but it's not necessarily 100% correct. So we came over here, and that's when I felt like there was a little bit of mismatch between what AI thinks we should do and what I think we should do. Yo, Blue. What's up? So, let's see. Let's go here. Where was that? I think the type checker on module. Yeah. So the issue was that I don't think we are going to have this kind of module type. It's simply going to be an execution result. That is what a function execution should be. But then the thing is, like, what we don't have right now in order to support that is having sort of like the execution result being well, I mean, technically we could probably have like a module type if you're using the import keyword. We are running the runic file as a function. Because the thing is, I don't really want to have a difference there, because if it can be the same like as running a normal function, why would we need a special module thing for that? We could just use the same return type as a function is giving you. So yeah, they should probably be the same. And importing is just a special way to call another function. The function happens to be a file instead of something that is declared in the file, in the script itself. That's what I'm thinking. So this type doesn't really exist anymore. So maybe we should ask AI to kind of redo the planning again with this new idea in mind, actually. Okay, importing a runic script is basically going to be the same as calling a function where the signature is defined by the signature of the script. The result should be an execution result, just as function calls will return. As per the implementation in place right now. once we have that, we also want to make all exported pub declarations, functions and bindings to be available on the execution result as well, like this. Const module equals import module rn, and then let's just say module dot greeting hello or something like that, where greeting is a function defined or declared in module rn and pub. So yeah, so it's kind of like they are, you call them as functions, what you get out is like a struct. Yeah, you get a struct out, but that struct is basically decorated with standard out, standard in, no, standard out, standard and what else? Standard out, standard and the exit code, like everything that the execution result has, but then also the pub exported declarations as well. So basically the result of the function call should be an execution result, well, should be a struct that has the execution result fields as well as the, and I'm aware that this might be weird because it's like the execution result fields, they are kind of special, so maybe they will have special names just to avoid collision, like name collision and other confusions. But we'll start here and we'll, that could be an add-on later. But here, so basically the result of the function should be a struct that has the execution result fields as well as the as well as the exported declarations as fields as well. All right, let's let it cook there a little bit. Excuse me. And yeah, so right, I don't really like how it's looking at the type checker so much, because that's not like that's like, this is like old code, so the new source of truth, you could say, is probably like in the compiler more so than in the type checker. So it should really be looking at that. Okay, here we go. It's already done. So why is it so slow here? Oh my god, I just pressed escape. Can you just resume? No. God damn it. Wait. No, sorry, I pressed escape by mistake. Could you please continue? I'm not sure if it can, if it's able to actually just continue here. Okay, there we go. Cool. Okay, let's see what it says here. So now I understand the model fully. Well, the execution result is a fixed 5-field struct. Standard out, standard merge, close. Okay, yeah, it did get this here. And exit code, weight, or computer from those at the type checker level. Right. A module, well, a type checker. Okay, well, a module imported. No, a module import result should be the same. Struct plus. No. Wait. Okay. Well, it depends. Like, okay, yeah. Yeah, the thing that's gonna be bound to the variable. Yes, that is correct. I was thinking like it should be a function call and not just a struct. But yeah, at the type checker level, it should just be evaluated as like a struct type. Should be the same. Should be that same struct plus modules pub decorations additional fields on top. Yes. Here's the updated plan which clarifies. Okay. So we have a design clarification. So module RN has a function. Well, this is okay. I don't actually want the module type though. But whatever. It doesn't really matter that much. Hello, Tech Check. You're streaming again? Yes. I was streaming I streamed yesterday. I had a little break because of sickness and like we were all cold and I don't know what it was, but basically I had to take care of my son and yeah, there was a lot going on last week, so not much streaming, but now we're back. I'm still a little bit under the weather, so I probably won't be streaming today for quite as long, but we'll see. Alright, so here's the module RN. How are you guys doing, by the way? Whoops. Oh shit. Windows. There we go. Okay. Module RN. Function void. So this is a module takes as a name as a parameter and gives us a module back. But this type here is not really. It's more gonna be the standard out type and not the return type. So this is the wrong type, but it doesn't really matter here. Alright, so we have like a version here. Okay, sure. We have a greeting function which is exported, which echoes the message out. And we have an internal thing which is hidden. Ooh. And we have another import. Oh, this is okay. So now we're in the second file, I guess. So we're importing that with Alice as the name. We're not actually doing anything with name in the code though. I find that kind of strange, but okay. Execution results, fields work as normal. Like I have a feeling that Codex. Okay, I feel like I'm bashing on Claude too much here, but I'm feeling that Codex would actually use the name for something. This is kind of the things, small things that I recognize that are different between the two models. Like Claude does these weird mistakes where I don't see Codex are actually doing. But anyway, maybe I'm biased, I don't know. Then so we import module here. So this is how you would import. You import the name of the file, the full name of the file. Well, this is a relative path, but it's, you know, with the extension, and then also a list of arguments, just like calling a function, except it's kind of like a special syntax here where you import a file instead. So this, you could say this is kind of like calling, you know, bash with a bash script and then supplying arguments. So that's, it's kind of the same, except this is like special in Runic, because I mean, you could probably just replace this with Runic, to be honest, and have it be like, but the difference is though that we're not simply calling Runic the executable and getting like a standard out result. We actually get a typed result back with things that are compiled as well. So the thing in here is compiled and parsed and all that. So it's like it all fits together. It's all type checked and all that. So yeah, it's different. I think import makes sense. We could say Runic here, although Runic I mean, I think no, I think import is good. Okay, so we import that. Now we can you know, we can get standard out, which there's no standard out here because we don't actually have any standard out. We could get the exit code, and we can also access greeting here. So we can access greeting on the module as we expect, and then we echo this message out, and we can also echo the version out. Okay, yeah, this is what I mean. This is what I was thinking here. However, I'm thinking maybe these things could potentially be under some because we don't want to have like naming collisions, so these might be under a special name. We'll see. Let's keep it like this for now. The import expression produces a single struct value whose fields are the union of the normal execution fields and all pub top level declarations from the imported file. This reuses the entire existing execution result infrastructure. Yes. And then, I mean, yeah, you could even, I mean, you could probably, no, I'm not gonna go there. I was thinking like getting an async in here, like importing with async, but no, like asynchronously importing another file if it takes like long to import or something. I don't know. No, probably better there. Excuse me. Okay, so let's see. So we're back here. So we have this thing, error if used inside a function body. I mean, technically a function could be used as a module, so really, why would it be an error, really? I mean, you call a function, the thing you get out, why would it could just as well be, you know, like a module that you get. Like why would we have this? This just limits what you can do. So I don't think this is this. I mean, I think maybe one thing is like it's going to be maybe confusing to have pub inside a function body, but it's like it's logical if it works the same. Although I don't know, it's logical when you know that import is a function call. But okay, anyway, I would like to have this. I don't want this rule here. Okay, AST pub is both. So we already have this here. Yeah, so it's already implemented. Scope is pub bool on binding entries. I think I added that. Yeah. Yeah. That is added. Okay, phase 2 import arguments. Okay, so we actually lost the thing that they had before. So that's fine, I guess. Phase 2 import arguments, same as before. Import arguments. So import expression arguments. Do we have an import expression actually? I think we do, yes. Importer module name and arguments. No. So a list of expressions there. Okay. I was thinking of something like, what if you had, let's say we had some kind of boolean some kind of bool that we get in, and then we have like an if b, we get like we only get this if b is true. Hey Paul, what's up? But I don't think we're gonna allow this, because then that kind of changes the type of the... I mean, if this is comp time known, this would work to be able to resolve the type of the module. But if it's runtime known, this is gonna be like an optional function, I guess. So we probably don't want to have that like we only allow public to be in like the top level block statements. Yeah, that makes sense. Okay, parse expressions after the string literal, same way arguments are parsed. So parser parse import. Right, the parentheses we can just get it the hell out of here. Parse, let's do like a function call. We have the arguments. I'm gonna check the execution call as well. Except we don't have execution call. No, that's just a function call, I think. Wait, parse identifier. Ah, here we go. Identify expression, that's right. So identifier. Wait. I think this turns the identifiers like into a call. we only have one thing. This gets this. This is then becomes a call. Where do we parse? Where this isn't even used. Where do we parse the thing? Oh yeah, it's a binary operation. Yeah, okay, yeah. Now I remember. Yeah, it's actually parsed as a binary operation where you have a call as the operator. The callee is the operand, while the left hand side and the right hand side is the argument. Right. So it's actually a binary expression. However, for import, I mean, maybe we just parse, like we parse the import token and then we parse. Well, yeah, we have to have a string, but then we have a. It's a comp time string because the module has to be comp time on. And then we have. What do we have then? We have a list of arguments. I mean. Yeah, it's not actually comma separated though. Delimiter, so I guess the delimiter, we don't actually have a delimiter, that's the thing. Maybe this should be like optional. And then what's happening here? Right, we're calling the parser, and I would do this. If it's not equal, we say we have a last item, and wait, the delimiter is wait, we return when we encounter. No, wait, when we don't encounter the delimiter after the parse thing, we do this dance here. When what are we doing? We're getting the last parsed thing. We're grabbing out the span, and then we return. Excuse me. We return the list if we don't encounter the delimiter. I think that this should only happen if we actually have a delimiter. So if what are we doing otherwise? We're taking the next token . Maybe we can do that. I'm not sure if you can have that in there, but this is just, I'm just gonna continue then. And that is like if this is equal to delimiter continue, I'm gonna flatten this. And I mean, it would make sense if we move this out. And then here we break instead. Okay. Just a whole bunch of logic in the while loop, like for exiting. Like it makes more sense to exit the while loop and then do the kind of final, you know, clean up and return there. Okay. I'm not sure if you, but what this is like, this is a continuation expression which happens like every time you continue or every time the loop like iterates. It happens at the end, so it doesn't happen the first time, like it happens after an iteration, basically you can say, but it doesn't happen like at a break. So the break will not trigger this, but a continue will trigger that. And there we go. That was a lot of errors. Okay, so now it's like, okay, well, do we have a delimiter? If we do, then we check if the next token is the delimiter. If it is, we just continue. If it's not, then it's something else that we need to, then we abort the whole thing. If we don't actually have a delimiter, we just continue. But how do we actually get out of this then, is the question. It's kind of weird. We have like a terminator here, but it's only checked at the start. I'm confused. Shouldn't it be checked at every point here? Also, what was the terminator for the one we did? So the delimiters comma terminator is this one, is expression terminator. So that is a whole bunch of different tokens that are usually that are terminating a thing. So we're checking first if we have a terminator at the start, but we should also check that in here as well. I think that we should probably grab the next here and check if it's a terminator. Actually, you know, I think I want to check delimiter first, because delimiter could technically be a terminator, I guess. So we'll do this. If we have a delimiter, we check the delimiter, and then we do that. But this branch also wants to do this. So and also this wouldn't be a return, this would be a break. Oh, I see. Because we have delimiter, so if it's not delimiter, it breaks. Right. Okay. So we don't need the terminator check here. Okay. But otherwise, if it's not a terminator, we should continue. There we go. Okay. So, parsing a list. This is very generic. It like can parse any type of anything. Basically, you pass in a parser function, and then there you can set some options, like if we allow skipping new lines, like if you want to skip new lines between each parse. And then we have a delimiter, which now is optional. So the delimiter, let's say you want to parse a list of comma separated expressions, then you would parse list. You would put in parse expression here, and here you would put in the comma tag. And if you allow it to be like different lines, you could put skip new lines here. So that's the idea here. So it's a very generic, like parsing a sequence or like an arbitrarily long list of expressions that could have a delimiter, but it could also not have a delimiter, because now we want to parse a list of arguments to an import expression. So I made this optional now. So if this is null, we are instead gonna check for terminators, which are things like right brackets, right parentheses, and stuff like that, semicolons. So okay, now we have an arguments list, and we can simply put that there. Payload. So there we go. However, this is not going to be a comma. This is going to be null. Parse expression. I mean, yeah. I'm just thinking, like, if this... Okay, we can try this now, actually. So we'll go to like importer, and we'll do runic print ast, and if we ignore this first part, oh, I see, this is the module that we imported, so that also gets parsed. So here's a binding. We bind module, annotation, that's what that means, type null, and then we import. Then we have an import statement from this place, and then the module imported is module.rn. Now it doesn't, we don't actually have the arguments in the print here, so we can't actually see, but we do see that, well, we don't actually have arguments at all, because we haven't actually added an argument here. But if we go over here, we can see we have a boolean argument. So if you say true here, expected value, actual new line. I also want to make sure that we don't have skip new lines. Should be false. It is false by default. So okay. Strange. So it did work when we didn't have arguments, but when we add one argument, it fails. It says actual new line, expected value, actual new line. What we could do is we could enable the log for parser. Wait, runic, is it log parser? Yeah, there we go. So let's see what path we're taking here. Okay. So we have a binding, and here's the expression we're binding to, which is an import. And we're parsing a string for the module.rn there. And here's the list. We're parsing an expression. We have a literal. Parse binary. Okay, and then it tries to parse the next expression again. Right, so we have the first one, and then it tries to parse the second one, which it shouldn't actually do, because this should be a terminator here, like that actually, yeah, okay. We're looking at the next, oh, this should be next here, not start. There we go. Okay. There we go. Now we have the import here, but we don't actually see the arguments here, so we should add that to the thing. So let's do like module and then arguments. And then this would be a loop. Actually, we probably want to have this new line, and then here we would do like level +2. Oh yeah, we don't need the indentation, but we want to do that. So that will print all that. Change it to like all. Okay. Now we can see that import. Oh. And we don't need this. Okay. Import from module, and then we have arguments. It's a literal. It's a true boolean. Awesome. Let's try adding another one. So hello. And now we get 2 arguments. Wait. Okay, now we get some weird thing here because it's like it's parsing this as a call, which does not make a whole lot of sense. Is it doing that if we do like this as well? That's like a parser bug in that case. It's a call. True is the callee. Okay. Yeah, that's not great. This should be some kind of syntax error over here. Yeah, we'll have to fix this. I'll just have to BRB 1 second here. Sorry. Alright, sorry about that. I'm back now. Let's see. So I'm thinking I'm gonna order some food, and when they get here, I think I'm gonna have to get off here. So 1 second. Oh. Hello, hello. What am I doing? I am creating a language, a scripting language that is kind of like Bash, but with zig syntax, you could say, and also Bash syntax. So right now I just discovered a bug with the parser. So yeah, what I'm working on right now is importing modules, and you can, when you import modules, you can also supply arguments to it. But I noticed a bug here where the argument is parsed as a function call, or a call here. Oh, according to me, like a non-coder, you're doing some alien stuff. Yes, exactly. Oh, sorry. 1 second. Okay, sorry, I just got a call from the restaurant, said that I only ordered a drink and a dip sauce when I thought I was, because I have this app where it's like it's yeah, it's kind of stupid, but I have this app where it's like it keeps track of what you ordered before. But the problem here was that the menu item was not available anymore, so it deleted it. So I just ordered a drink and a dip sauce for basically a full meal's pay. Like you pay for the whole thing because they have like a minimum amount. So I have to cancel the other one if I can. From yesterday only I was learning UI UX. I guess that's why YouTube suggested me your live. Okay. Yeah, I also get a lot of Indians on here. I don't know if YouTube is recommending me to because there has been, or if it's just the time of day that matches. I don't know. Okay, yeah, that sounds really nice. Butter chicken and naan. What is roti? But yeah, I really like butter chicken and naan. God damn it. Okay. I think my order was cancelled. No. Okay, whatever. I think it's good, yeah. Yes. Okay, but we do have another order in. Okay, there we go. Cool. It all worked out in the end. There we go. Hello, Polaris. Thank you. Have a nice day yourself. Your time matches with ours, I guess, because it's evening here. Yeah, for me it's noon. It's almost 12 o'clock right now. Yeah, I guess that makes sense. Yeah, it was a mix-up with the ordering, or a mix-up. It was like the app remembers what you've ordered, and there was one item on the menu that on the order that didn't exist anymore because they have this like recurring or they switch out. It's like burger of the month, so they switch out each month. But I thought that it was gonna, add the current month, but it actually it didn't actually add the item at all. But I didn't see that, so I ordered anyway. And that is like, since it has like a minimum of, how much would that be? Like $12 or something in US dollars if you want to use I guess something that people can have calculate from. Minimum, I ordered a drink and a dip sauce for $12, you could say. But then I got it cancelled and made a new order. The fun fact: I'm studying for medical exam but learning UI UX for web and Android. Oh, I see. So are you more interested in web development, or is it just interesting, like you do it for fun? Okay, anyway, so true hello. So this one, we have to fix this parsing issue. This would be the binary. Because a call is a binary expression where it's like the operator is not actually a token. It's more like the absence of a token. So when we get to the operator and it's like checking here if it's range, if it's this, otherwise we append and apply operator. So that is the operator of calling something, but this is not actually what we want. If it's only, we want only this if the first expression is this is you know what we really want to do is probably parse. Let's go parse import. What we really want is probably parse a binary from here, because the module name will become the callee, which makes sense, and then these would be the arguments to that. So let's actually do a call expression here. So this would be the binary. But if we don't get this, there's an error here. But this is the entry point for the binary, so we have to call this. But or else this would be like some sort of parsing error here. I'm not sure what error this would be. Expected. I'm good at art, and there is some bug in my ass. In my what? I'm good at art, and there's some bug that says to do different things. Oh, I was thinking a computer bug, or I don't know, that says to do different things. Like I learned Blender 3D animation, HTML, CSS, Basic, Python. Oh, I see. Oh, so you're just learning all different things. That's cool. You should. I mean, I think everyone should try things out at least once, to because you never know. Like before I tried programming, I had no idea how much fun it could be. Yeah, I was looking for an error that could explain this, but whatever. Let's just do that. This one would be start. Expected module import. And we don't actually have anything to show here, actually. So actually we could take next here. There we go. Okay, so that's the call. Now we want to inspect this afterwards to see that it's actually a call, because this, now we're in import, so the import would expect the next thing to be a string, or actually we would get a call, so we would expect the call to be a call expression. And then we could expect I think we'll do this. If call is not equal to call, then we have another error, which is basically the same thing here. Now we know it's a call, so we can simply say we also expect the module name to be a string. So the call.callee, wait, you have to be a string. Literal. Wait. There is no. No. Oh, it's a literal and then a string. I mean, this would be an OR. And an unexpected module name as a string literal. Module file name, I should say. And here we can actually use call.span. Well, actually we could use call.callee.span. And that's the span we want to show there. Okay. Here we can use call.span. All right. Okay. So now the module name is going to be, well, okay, that's the other thing here, is like the first string has to be without interpolation as well. So actually we kind of need to do this. So string literal to string, I guess. There we go. Old naming convention. Okay. This is the string. We don't need to copy it. Okay. Now, back to the thing. No, string literal to string, yes. And that's call, literal string. That gives us a string. There we go. Now, and then we have arguments, which we already have them from call arguments. And there we go, that's the arguments. What else do we have from the call? We have a span, background. So yeah, technically that could be parsed as a background process. I think we're gonna kind of not allow that. Also redirect. I mean, yeah. Because it's basically just a function call, so it would make sense to actually allow these modifiers anyway. But so maybe this should just be a call actually. Maybe we should just, but we do want to make sure that it's a correctly formatted call. But once we have the things, and an import expression is special, but we could no, let's, you know what, let's just make this, let's just have this call expression here. No, it's not an array, it's just a call expression. The callee is the module name, so that is duplicated, but whatever. We do want to have the other things on the call. Whoops. God damn it. So let's go. Right, so call. So that's just a call expression there. Okay. Right, so actually we basically just want, we want to show the call here. So we could just render the expression, the call expression actually. Call expression. Where is the call? Oh, it's just this. Okay, sure. Well, okay, let's do render call expression, and we'll move this out and make this yeah, and then we also actually need the call expression. Alright, and we don't need that. There we go, and this should be like level +1. Okay, so now we have import. If we go back here, so we have this this is still a call. I mean, this should really be a parsing error, this right here. I'll just, you know, I'll just put this in the to-do. Okay, and I will remove that. Okay, now, first we have the binding module bound to an import. The import is imported. The module is module.rn. This is a duplication, but whatever. We have the call. We have argument is a literal true. Argument 1 is a literal string segment hello. So cool. So we get the benefit of all the things that calls can do, but for imports as well. So if we redirect that to this, we also get the redirection. Although we're not showing the redirections here yet, but okay, whatever. It should work. Because it's basically going to be the same as a it's simply going to be a function call. So in the end, it should work the same. Okay, and with that, we now should be parsing this correctly with arguments. So let's go back to Claude here and see what the next idea was here. So we have this, sort of. Let's see. Parse expressions after a string literal, yes. Parse import thread arguments through for pre-parsing. So document store has modules AST ready. Yeah, that is. I think that's already implemented. We don't need arguments, though. Like the arguments shouldn't matter for the parsing. It matters for type checking, but not for parsing. Like with the arguments, why would we want to parse put the arguments there? I don't know. Phase 3 module return type keyword. Yeah, I don't think we're gonna have that. It's going to be void because the output is not like. It's what's returned, like the type that we're talking about here is what's returned in the pipeline context, not in a binding context. So this is not correct here. Okay, it continues down here. So this shouldn't actually be done. This shouldn't be done. The script is a module. Files with no signature also implicitly module. All files are module, and in fact, all functions are technically modules as well. You call a function, you basically get a module out. If like, it's just a label. We label something. It just happens. It's a function, and it just happens to be in in the form of a file that we import. Run import expression checks the target script signature, validates arg count enticement. Yeah, I'm not sure if we've done this. Like all of this, I don't think we need to do. This one we do need to do here. So let's go to type checker. Do we have any import? Yeah. So we have the module type. Whoa, what's going on here? Okay, this is just logging over here. Span, and we get the span, and we get a writer. And we write a bunch of things. I think this is only for logging. And then we resolve the type. Here's the actual code. We resolve the type through the expression, which is just, well, this is gonna be an import expression, and the type we're actually returning is a module type. So we don't have a lot of things on here. So the import itself, this is wrong actually now. We need to wire this up to make it actually like an execution result type, but the type checker is kind of outdated right now. It's a lot of fix-ups needed for the type checker. So I think I'll leave this for now, because the type checker needs more work to catch up with the functionality that we did in the compiler and stuff. So I think I'll leave the type checker, and I will continue on with the actual implementation first, and then deal with the type checking. Module result in the type system. Right, so we do need to have a struct type that is kind of constructed on the fly. It's like com time. Oh man, I'm feeling tickling because I can't speak that much today because I'm a little bit under the weather here. Yeah, I'll probably have to quit here soon, but let's just see. So what we need to do is we need to construct a struct type dynamically during I mean, it's gonna be during the type checker step, I guess. Alright, cool. Food's here. Perfect timing. But yeah, so that would be the next step. We didn't get to do a whole bunch this time, but we did do a little bit of progress. I think that probably the modules are gonna be the last thing that I do before. I know I moved the goalpost here quite a lot, but this is the last thing I'm gonna do before I will switch back to my other projects. So so yeah, then I'll be happy with Runic, and I will actually start using it, I think. Yeah, so then but yeah, that's gonna be it for this time. So thank you very much for joining me here today, and I hope you have a nice day, and I'll see you later. Bye bye.